Hello everyone. So today we will be having our lecture 2 of our topic basics of trigonometry. So yesterday, just to quickly see what we did, yesterday we studied about two topics that were one, we studied about trigonometric functions and how they are related to right angled triangle, right? And also we saw second topic was our study of fundamental unit, that is degree and radian of an angle, and how degree is related to a radian, and how an angle in radian can be converted to degree and an angle in degree can be converted into radian. So this was specifically the two topics we studied yesterday. So let's move on further. Today we are going to start with another topic, that is waveform and related terms. So this is a very basic waveform I am showing here. This is basically a sinusoidal waveform which is representing a sine wave, right? Just to keep currently in mind that sine wave is nothing but a sinusoidal wave which is repeating itself after certain intervals of time. So waveform, regarding this particular topic, we have certain terms which are amplitude, period, vertical shift, phase difference, and path difference, which are very important to understand what exactly and how does trigonometry and related applications work. So let's start with our very first term, that is amplitude. Let me quickly define it. So amplitude is defined as the amplitude is defined as half the distance between the maximum value and the minimum value of the waveform on y axis. And also we have a second definition, that is waveform could be defined as, amplitude could be defined as the height of the curve from the center line, right? So here in the wave, I've already shown what is an amplitude, right? Just quickly, if we refer the definition, we see that this is the maximum value where the graph is attaining on the y-axis. This is the minimum value, right? Amplitude is always shown on y-axis, right? And here time is shown by the x-axis. So difference between the maximum and the minimum value, that is the maximum value, right? That is a on y-axis, and minus a, that is the difference. So according to definition, what would be our amplitude? So amplitude would be simply the difference, that is the maximum and minimum value, difference of maximum and minimum value divided by 2, since it is half. So we have 2a by 2 is equal to a, which is here the amplitude, right? So this was the amplitude, and the second definition, what the second definition says, that maximum height the curve of the curve. So this is the height of the curve with through the central line. So x-axis is considered to be the central line. Okay, so this was our amplitude. Let us now move on to what is the period, right? So period or t is defined as the time taken by the waveform to complete one cycle or one oscillation. And let me just tell you what is the cycle or oscillation, right? According to definition, it is the time taken, right? Time taken. So we represent the x-axis as time. So time taken here, let's say t. So we see that in the waveform, it started initially for t is equal to 0, and then it moved through then it moved through this path, right? And here at point T, again it started moving on the same path, right? So here we can see that at time t is equal to 0 and after time at t is equal to t, right? So the wave has started the transversing same path, right? So this point to this point where the wave again transfers the same path, so this particular path would be called as the cycle, right? So what is the cycle? One cycle is the path covered by the uh, waveform, right? Until it repeats itself. Fine. So we can say that time period right? This is nothing but the time to complete one cycle, right? So I hope you have got what is time, right? So here, this particular time where till which it repeats, it will be called as the time period, right? So this is till time t. This is our time period. Fine. So let us understand this with a very nice example and live physical example. That is, let us take the example of a pendulum. I hope you all know what is a pendulum. So how does a pendulum works? We will quickly see that and how we can relate the waveform of a sinusoidal wave to the motion of a pendulum, right? So this is the pendulum, right? Let this be the mean position of the pendulum. Let us denote it by O, right? And what is the path followed by the pendulum, right? That is a 2/4 motion or a periodic motion. So here, let the pendulum move till the point A. Since this is on a positive direction, let us make this be the positive direction, and here pendulum moves. Suppose this be the negative direction, right? So these positions are also known as the extreme position, since this is the maximum position or maximum limit till which the pendulum will move in a to and fro motion, right? So this is basically how is it moving? It is moving in a periodic motion or a to and fro motion. So what would be the path followed? The pendulum will start from the very mean position, move to the positive y-axis and attain a maximum position of A, come back, right, and come back to the mean position again. From here, it will go to the extreme position on the negative side, that is minus A, and again it will come to the mean position, right? So here we can see this particular movement of the pendulum, right? And again, it will not stop here, it will again follow a similar path and continue moving in a similar path, right? So this one complete oscillation, right? Why I'm naming oscillation? Because these are different. Say we have one cycle, we have two cycles, then we may have, right, some, say, n number of cycles. So these 1 2 3 cycles, these are also known as oscillations, right? So what a pendulum is doing? Pendulum is moving in a periodic motion, and from here we can say that periodic motion is the motion of a particle, right, or a body in which it repeats its path after regular intervals of time, right? And what are these regular intervals of time? This is nothing but the time period. Okay. So, if we take an arbitrary case, right, let the pendulum complete, say, 16 oscillations, right, in, say, 5 seconds. Since it is moving very fast, so we'll compare it on a lower amount of time. So, from here we see that one oscillation will be completed in how much time? 5 by 16 second, right? So this 5 by 16 completes in one oscillation, it completes in 5 by 16 seconds. This is nothing but one cycle. It is completing in 15 seconds. Sorry, 5 by 16 seconds, right? So oscillation in form of waveform is nothing but one cycle of the waveform. So let us now quickly see how can we compare the motion of a pendulum in a waveform, right? So this is the time, maximum time t, right? Now, what is the motion? How did we see? This is our initial position, right? Then pendulum moved from the initial position to the maximum position where it attained A position. This was our extreme position, right? And here this is our mean position, right? Again, pendulum comes back to the zero or the mean position, right? Then again it will attain maximum negative side position, that is again our extreme position, and again it will go back to the mean position, right? So now we see that this particular cycle we will be repeating on this particular waveform, the cycle will again repeat itself, where this is the extreme position, right? This is again the mean position, this is extreme position on negative side, and this motion will continue, right? So this is a periodic motion, right, with a time period t and amplitude a. Okay, so I hope through this example you are clear with the period, right? And let us move on to the the what is vertical shift, right? So let me quickly copy this particular diagram so it is convenient for us not to move again and again back to the top of the screen. Let me just copy it. So here, this, right? This was our basic diagram which we took. So next term we have is the vertical shift, right? The third term we are going to study is the vertical shift. So vertical shift is the perpendicular displacement of the waveform from the x-axis. So here in the waveform, how we can depict or present, understand the vertical shift, right? So suppose our wave that is shown in the diagram is not starting from the y not starting at 0 on the y-axis, right? But it took some another path like this. So this particular wave started from this very point, and this was the 0 reference, right? So what will be our vertical shift? This particular displacement will be our vertical shift, right? So this was our vertical shift. Let us now quickly look at what is the phase. And the next terms which I am going to explain are very important to understand how does a sine, especially how does different waveforms work, or different waveforms change their path, and how does different waveforms can be compared to one and another on a graph, right? So the wave phase is the position of the waveform at some fraction of period, right? So fraction of period, that means our time period is t, right? So in the diagram, let us understand what is the fraction of period. So fraction of time period, right? So this is the complete cycle, or this is the time period in which the wave completes one cycle, right? So let me just divide this wave into four equal parts, right? So when we divide this wave into four equal parts, so this will be t by 4, right? This will be t by 2, this will be 3t by 4, and this is t. So this t gets divided into four sections or four parts, right? So now it is saying the position of the waveform. So let me just let you know, this is a very basic waveform, that is sinusoidal, right? So we will just understand how sinusoidal waveform is presented in terms of equation. Let this be the waveform, and here we will see that a sine omega t is something, the very basic sine wave, right? So here a is our amplitude and sine would be the present the form function. So here we are taking a sine wave, so we have taken the sine function, and omega t is nothing but our phase, where omega is, what is omega? Omega is our angular frequency, right? So let us just understand. Let me just quickly draw a table. So, right, so mm, uh, this is table, right, where we can quickly understand how different values could come, right? So let this be the value of t, let this be the phase, right? So we know that we let's start with the time 0. So this is our time 0. This is t by 4. This is t by 2, 3, t by 4, and t. Right. So these are the different time, or the time different time which the wave attains. Right. So we know that time period of a sinusoidal wave. Right. So that is omega t. Right, so omega t is 2 pi, fine. So this is the time period, right? So just let me tell you here, t, this particular t has a phase of 2 pi, right? So 2 pi divided by 4, that will give us a value of pi by 2. Here the value will be pi, here the value will be, here the value will be 3 pi by 2, and here the value will be complete 2 pi, right? So what are the phase we are getting? At 0 we are getting 0, right? This is I'm talking about the sine wave. 0, then we have pi by 2, then we have pi, then we have 3 pi by 2, and this is 2 pi. Fine. Now let us just quickly compare this table with this wave, right? So what our table says, so just let us put down the values in this particular, is our wave, right? So what is the A, that is sine omega t, right? So this will be omega 0, right? And this is sine 0, right? That is 0. We know for sine 0 the value is 0. So we can write here yt is equal to 0. Fine. Then further, at t is equal to t by 4, we have omega t is equal to pi by 2, right? So a sine pi by 2, we know pi by 2 is 90 degree. So a sine 90 degree is what we are getting amplitude as a. We can write here a sine. Then moving on further, at t is equal to t by 2, omega t will be pi, right? So this will be completely a sine pi, and this is what a sine 180 degree. So a sine 180 degree is 0. Again we have the value 0. Fine. Moving on further, at me write here 0. Moving on further, at t is equal to 3t by 4, we have omega t or phase is equal to 3 pi by 2, and here value we attain is a sine 3 pi by 2, right, which is simply, if we calculate in degrees, that will give us 270 degree, right? So you can use the conversion factor to calculate radian into degree. So what is sine 270? So for the time being, let us remember the values only, because later on we'll study the quadrants, so we'll understand like how these values 1, 0, -1 are obtained by the sine function. So this is our minus a. So let me write here minus a. Fine. Now let last we have at t is equal to t, that is complete period, we have omega t is equal to 2 pi. So a sine 2 pi is what? A sine 2 pi is a sine 360 degree. So this is a into 0. This is 0, right? So what do we see? We see from the table that sine wave at 0 degree, right? Sine wave at 0 degree, this was the maximum amplitude A, and this is the maximum amplitude in the negative direction, negative A. So when a sinusoidal was at t is equal to 0, the value was 0, it attained the maximum value, right, at t by 4, that is pi by 2. Then it moved to t by 2 pi, where it attained the value 0. Then it again 3 pi by 2, or that time here was 3t by 4, it attained the minimum or the negative value, right? And again at t is equal to, it completed its one cycle. So what is happening here? Basically, we need to remember that amplitude is not changing. Amplitude is fixed for this wave. What is changing in this? These are the different phases which are changing at different times. So here this was 0, here it was pi by 2, here it was pi at this point, here it is 3 pi by 2, and here it completes 2 pi, right? So we can say from the definition, let us come to the definition again, the position of the waveform at some fraction of period. I hope you have got this particular line now, and also you must have deduced that this particular phase is an angle, right, and is measured in degree and radian, right? So this is what is our phase. Fine. So this was the all about phase, right? So let me just make you understand now what is Okay, so let us quickly understand now what is phase difference, right? So I'll just copy this. So today we saw what is amplitude, what is period, what is vertical shift, and what is phase. I suppose let us take the phase difference and path difference in the next lecture, since the lecture will be very long and it will be a very it will be a time-taking process. So let us take this lecture tomorrow in the next lecture, that is lecture 3. So tomorrow we will be studying what is phase difference and what is path difference and the relation between the phase difference and path difference, right? And if time allows me, we will take the further topics that are related to the diagrammatic representation of the different trigonometric functions in a unit circle. Then we will be taking the topics like quadrants, like how quadrant is helping us to understand the different values of different trigonometric functions. Then next topic will be our graphical representation of psi of different trigonometric functions. So these are the few 4 to 5 topics I told, which I'll be taking in my next few lectures. So please be patient to listen me, and probably if you're liking my videos and are enjoying them, please do like, subscribe, and share with your friends so that I can reach to more and more people and they could be benefit from the same videos. Let us wind up the lecture for today and hope you people are learning and working on your concepts. So maybe these videos would also help you to uh, help you to more conceptualize yourself. So thank you for today. Like, subscribe, and share if you're liking it. So since appreciation is something which keeps us motivated. Thank you. Thank you for today.